Welcome back to the Speed Beast YouTube channel. This is LS7 Devin, and today I'm going to show you how AC systems work in cars and also how the heat works. If you ever wondered how all that worked, I'm going to explain that in like 4 simple steps right here, just really quick. So let's jump right into it. Make sure you smash that subscribe button. So here's your AC compressor, and it's driven by a belt that's connected to your crankshaft and a bunch of other pulleys. So if you can see that right there, that is your engine. And then right here in the red, we got high pressure gas. That's what comes right out of the AC compressor. AC compressor is like a swash plate pump, and it just pumps the refrigerant, because there's like a couple different refrigerants you'll have in here. R134A, they don't make R12 anymore, just a refrigerant, that's all you gotta know. And since it heads out of the pump, it's in a high pressure gas state, and then it goes to the front of your car under your hood. This is the high side of the AC system. If you ever hear high side and low side, this is considered your high side. And right in the front of your car by your radiator, down there by the grill, like where intercoolers are and stuff, there's a condenser. It's like a radiator that has refrigerant going through it. That's all that is. It's all you need to know. And wind goes through it because it's in the front of your car by your grill. And what happens is when the refrigerant is a high pressure gas in this little line under your hood, then it goes through the radiator and wind cools it off. It turns into a high pressure liquid, the refrigerant. So the refrigerant goes from a high pressure gas through that condenser / radiator thing, turns into a high pressure liquid. Then there's always a receiver dryer. That basically just filters the whole system. Most modern cars, it's connected to the condenser on the front of the car right on the side. This is a filter, and it also gets a little bit of moisture out of there, out of the system. And then you'll find your high pressure switch. So just think of that as a filter for the AC system. So like when the pump's running, making metal shavings, they get caught in the receiver dryer. Filters them out so it doesn't ruin your system. Then you got your high pressure switch. What that is, if the refrigerant pressure gets too high, it'll turn off the pump, so it won't pump over a certain pressure. Because if the pressure's too high, it'll blow up, and that's not good. There's also a low pressure switch, but we're not there yet. So let's recap real quick, because I'm just trying to, if you're studying for an ASC, this is a great video to watch because I got all my ASCs. I'm just going to teach you real quick. If you understand these steps I'm going to go over, you will completely understand refrigerant in even in your house, everywhere. This is how it all works. So let's go over this again. We got high pressure gas coming in here. Through that, turns to a high pressure liquid, through the receiver dryer. As long as the HP switch, high pressure switch, it's just an electrical switch, like a valve. It's just a switch, on and off switch. As long as the pressure's good, which it should be, it'll go through here to the expansion valve, and this is where all the magic happens. So an expansion valve, what happens is it turns the high pressure liquid, it vaporizes it into a vaporized refrigerant liquid. Now, the way I like to explain it, just what makes sense for me, is say this is like a paint can, like a rattle can, black spray paint, and or blue, because blue. There's blue paint coming out of there. Whenever you shake the can up and spray it, what happens is you have high pressure in here, and you have low pressure out in the atmosphere. So in the can, there's like a ton of pressure. Shake it up, it's under pressure, and then you spray it, and you release it into a low pressure. High pressure going to a low pressure cools it off. So this gets colder, and also the paint coming out is cold. Everything's cold. If you sit there and spray a can for like 10 seconds, 20 seconds, you'll notice it gets really cold. That's basically what's happening inside, but with refrigerant instead of black paint or blue paint. God, I keep fucking that up. This is where the magic happens in the refrigerant system, because it's just never ending, so it gets recycled. Because that would end up running out in like 30, 40 seconds, maybe a minute or two. When you shake up a can and spray it, it would run out, where an AC system keeps recycling it, so it's shooting cold blue paint, but refrigerant in here, and it's just getting cold, cold, cold. It's running for 20 minutes straight. This thing starts frosting up, it gets so cold. So that's what happens here. Now you have your refrigerant, now you just gotta blow that on the person. So under your dashboard, you have an evaporator and a fan. Just blow, fan, you control the speeds, just blows on the evaporator that has cold refrigerant in it, which is just another radiator. It'll be a freezing cold radiator right here. And it'll cool off the passenger or the driver or whatever. And then it returns back to the pump and repeats. And then you have a low pressure switch right here. If the pressure gets too low, it turns off the pump. So the AC pump compressor, it's a pump, makes a high pressure gas, goes through this condenser, turns to a high pressure liquid, gets filtered through this receiver dryer, still a liquid, then goes through the expansion valve. As long as the pressure is good for the switch, and now it cools off. This is where it cools off, turns into a refrigerant, blows air on it, and then it changes back into a low pressure gas when it goes through this evaporator. So you see how that's green? It's a low pressure liquid that's freezing, goes through the evaporator, picks up some heat but not much, and then it turns into a low pressure gas. So if you're studying for your ACs, you need to know when it's a gas, when it's a liquid. It's gonna trick you on that question. You need to know that, and especially when you come to diagnosing systems, if you understand this, it makes you like way more intelligent than just being able to hook up some fucking gauges to it. Like, you need to know this stuff. So this is really important. If you don't get it, just rewatch that a couple times. This is super important to know. And understanding that, I hope that made sense to you when you saw that. But now let's go over the heat. This is really easy. You're going to do this real fast. So same kind of system. You got your water pump right here. And here's your system. There's coolant going through here. Like your engine has coolant in it. It goes through a radiator to maintain the temperature so it doesn't overheat. And that coolant gets hot. It's like water. You could put water in there, but it's not. It's coolant, so it doesn't freeze in the winter. You should know that, but if you don't know that, it's just hot because the engine's getting hot. It's going through the engine, then going through a radiator, and just maintaining a temperature of about 215 degrees. Your coolant temperature. It's like operating temperature. Then you get your thermostat. So what happens is water comes out. Say this is your engine with your crank, and that's your water pump. Well, your water pump pumps it through the engine, picks up a bunch of heat, and here's your thermostat. If your thermostat's closed, it'll just go right back to the engine and keep heating up. And a thermostat, like, it opens when it reaches a certain temperature. It's like a device. If you dropped it in boiling hot water, the valve would open. That's what kind of valve the thermostat is. It's temperature sensitive. So when this coolant reaches like 195 degrees, it'll open it and let it start cooling. But no matter what, when the car's cold and you start, you have coolant going back into the engine and through the heater core, because those are the two most important things. You want to get the engine up to temperature, and you want the driver to have some heat to be able to drive, and not freeze. And so that's basically what's happening. As the car warms up, thermostat opens, everything opens, but at all times, no matter what, there's coolant going back into the engine, warming up when it's cold, and going to here, through here, and through a radiator, which a fan blows on it, and that's what creates heat. And then it goes back to the engine. So it's coolant instead of refrigerant that actually gives the driver heat. And then the last thing I got right here is showing you how the fan, because all these have a fan that blows on this. And you know how in your car you have your fan control speed, how much wind is going to be blown, and then you have your temperature control, and then you have your modes where you select feet, head, defrost, all those settings. Well, I'm going to show you in this. So this is basically the system under the dash. You have your fan, and then you have these, which will control your hot and cold. But this one's open. So as you can see, wind's going to come in, and then, so just natural temperature air, ambient temperature air will come in and be blown from this fan, and this door is pretty much closed. Maybe a little bit will go through, but not much. It'll all go through here, and then when it goes through here, it'll get heated up. And then there's these doors here. This would be for your defrost, for your windshield. This would be for the passenger's head. But as you can see, these valves are closed. This one's open, so all the heat's going to here. Now these are like actuators. Some of them have like 3 positions. Some of them just have on and off. And there's like blend doors and mode doors. I don't exactly know which one is which. Put in the comments which one it is if you know. These would be considered blend doors because this is going to blend the hot and the cold. And these would be your mode for your feet, your right at the face, or your defrost. And these are controlled, your fan's just controlled with a 1, 2, 3, 4 switch. And then these are sometimes cable actuated, or they're just electric actuator. And that's all that works. I hope that made a lot of sense to you guys. Please smash subscribe, and I'll catch you in the next one.